I received an overwhelming number of comments on YouTube asking what I thought about the JayzTwoCents video he did on fixing a broken pin or broken pins on the Ryzen CPU. I will say to you, just like I said about Linus, JayzTwoCents is not a micro soldering expert. You cannot ask me what I think about how he did. Linus is not a micro soldering expert. Linus tried to solder a micro HDMI connector on a Sony camera and he failed miserably. JayzTwoCents tried to replace broken pins on his Ryzen CPU and he failed miserably. But JayzTwoCents tried once, 2 times, 3 times, 10 times, 20 times. He was able to get few pins in place, but he gave up. He gave up on the CPU. Now I do have a donor CPU on my bench, a very old donor CPU. Maybe we can go over it and I'll go over what it takes to remove a pin and to solder a pin on a CPU. I'll go over the mistakes that Jay did when trying to replace broken pins on the CPU, and we'll take it from there. Number one, you need a very sturdy board holder. You need to secure the CPU in the board holder so the CPU does not wobble or move when trying to desolder or solder a pin onto it. I have the CPU in the board holder, a very heavy board holder. All the tools that I'm going to go over today in the video can be found and purchased off our site. Let's go under the microscope. Now that we have the CPU in place, the second thing that you need and is a must is a microscope. I do not care what microscope you have, as long as you are able to see the pins, then that microscope will do. We have a very high quality microscope. I can zoom in. I can probably see the texture of each pin if I want to zoom in. We have the best quality microscope that you can get your hands on. And I'm not saying this because we sell that microscope. I'm saying this is because I use it every day and you can tell. Just compare the quality of our videos when micro soldering to other content creators on YouTube. Number 3, you need a fine tweezer. Jay in his video was referring to his tweezer as being fine, but I want you to take a look at this. Take a look at the tweezer I have here. I can grab the pin from the very bottom, from the top. I can grab the pin right next to it, the one right next to it. I can grab this one, I can grab this one, I can grab this one, I can grab this one. I have full control over every single pin on the CPU because the tweezer is super fine. Take a look at the tweezer that Jay was using in his video and take a look at this tweezer, and it makes a huge difference. With a fine tweezer like this, you have full control. I can grab and hold on to that pin and the pin is not going to fly away. It's not going to go to the 9th dimension. And that's the type of tweezer you want to use when working with microscopic pins like this. The tweezer I'm using is the NF-S tweezer. We also carry the NF-B. S stands for straight, B stands for bent, and NF is NorthridgeFix. Number 4 is the hot air station. Now for this purpose, I think any hot air station would do. Any hot air station would have sufficient heat to remove pins off a CPU. I'm not going to say anything bad about the station that Jay bought, but do not buy the same station. I'm against the all-in-one stations. He bought a station off Amazon that has a hot air station, soldering station, and a power supply. You're going to get a crappy hot air station, a crappy soldering station, and a crappy power supply. You may be able to use the power supply to charge your devices, to supply 5 volts. It's not going to matter that much, but hot air station and soldering station, you're just wasting your money. It's like buying a billiards table, a pool table that has a ping pong table. You can add a board over it and then it turns into a ping pong table, and then you flip that ping pong table board and it becomes a chess table and other snake and ladder games. Do not buy tables like this if you are serious about billiards or if you are serious about ping pong or whatever the case may be. So for the purpose of desoldering pins off a CPU, the station that Jay bought is sufficient, is enough to do the job. But for anything else, I think he's gonna struggle, and he already struggled with the soldering iron where he was not able to get solder to stick on the tip. We were sent an I2C station to review, and I went over it. This one right here. You can check the I2C video we did on this one. It's called I2C, and the station looked like it's a quality station. A lot of weight to it, and a nice display here. The buttons, they seemed sturdy. When I used it, it was crappy. Why? Because of the tips. Solder would not stick on the tips, and sometimes the station would not see that I have a tip plugged in. So I did not give it an F, I gave it a Z. I did not give it anything, but it was a fail. It was a big fail. And we told the company that we're not going to carry that station because I cannot sell anything that we do not approve. And the same thing happened with Jay's station. The soldering iron was horrible. Anyway, I do not want to talk bad about the tools that he has, but I can give him recommendations. I'll just go over the pins. I'll go over some tips and tricks, and then you can figure stuff out on your own. Now that we have the tweezer, we have the microscope, we have the hot air station, we do not need flux as of now, but we're going to use flux later. Let's try to desolder a pin. Before we attempt to desolder a pin, I want to go over the nozzles. I'm using not a very small nozzle and not a very big one, a medium one. You have to understand, the bigger the nozzle, the more heat transfer. The narrower the nozzle, the less heat transfer. And a narrow nozzle will cause air to push out hard. The nozzle looks something like this. I'm going to lower airspeed and maybe set temperature to 390 C. What's a good hot air station? The Aten hot air station that we sell. Just log into NorthridgeFix.com, click on shop, and search for Aten, A-T-T-E-N. One of the best stations for the money. You can go crazy with JBC and buy a $2,000 station, but the Aten station is the best value for the money. Now the first thing we're going to do is grab onto the pin. Let's grab onto this pin right here. Done. The pin is out. Let's say I put the pin back on the holder or back on the bench. Now I want to grab that pin and solder it onto another CPU. We're going to solder the pin onto the same CPU. We can use solder that is left on the CPU, or we can apply our own solder. If the pad does have solder on it, then I will not apply any solder. If it's not broken, do not fix it, because you can create other problems when you are trying to solder a microscopic pad like this, especially if you do not have any experience. For the sake of this video, let's say we want to apply solder onto this pad. We need flux, and that's what, number 4 or number 5? We need flux. Amtech 559 flux. Do not use cheap flux that will stick like glue on the board, or that will give you a yellow tint or a brown tint, or that's gonna be hard to clean. Use Amtech flux, Inventec Amtech flux. We are a distributor of the flux, and Amtech is the best flux in the market. I applied just a tiny bit, and I'm going to use our NF.mini pen, but before we solder anything, we have to have the fume extractor on. Do not inhale the fumes unless you do not care about your lungs or your health. Fumes cannot be good for you. Fume extractor on, and we're going to grab a very fine soldering tip. For this purpose, I'm using the NF.mini pen, and it looks something like this. I'm using the knife tip. We also have a conical tip and a bent tip. A knife tip will work perfect here. To activate the pen, all we have to do is touch the button. We do not have to press it, just touch. And once I touch the button, temperature will go up. When I release my finger, then the pen will go back to sleep. So just touch the button. And why not use our anti-glare light instead of the ring light? Let's turn off the ring light and use our anti-glare light, and let's see what difference it makes. Look at this. We can see the texture of the solder. We can see the texture of the board. Amazing. We can also use the combination of the ring light and anti-glare light. and you get an image like this. I applied flux right in the center. You can tell. If I turned my ring light off, then you're not going to be able to see the glare of the flux. It's going to be very hard to tell where we applied flux. Let me turn the ring light on, and maybe I can apply more light or less light. You see how we get rid of the glare because we have our anti-glare light on. Let's apply solder onto that pad. Again, we're going to touch the button on the NF.mini pen, and we are currently at 430 degrees Celsius on the tip, and I'm going to apply a little bit of solder on the tip, and look at how solder sticks onto the tip. That's a good quality tip. Look at this. That's it. Done. Let's apply solder onto the last pad. We do not have flux on the last pad. I just want to show you what happens when you do not have flux on the pads. I do not know if I still have flux on the tip of the iron, but let's try it. I got solder to stick because we probably still had flux on the tip. I'm trying to mess it up so I can show you what happens when we do not have flux. Maybe we'll try it later on. Let's go ahead and solder the pin. We need to refocus to see the pin because the distance between the CPU and the pin is about a quarter inch or half an inch, so we lost focus because we are zoomed in. I'm gonna grab the pin, and then we can straighten that pin with the edge of my holder or the edge of the bench or whatever the case may be, like this. Let's focus on the CPU, and we can also zoom in. All right. You do not want to squeeze too much on the pin because you're going to end up snapping that pin off the tweezer. We're going to apply hot air. And we are done. Now we can fix that pin. Once that pin is in place, if it does not look good to you, then you can fix it. But now you do not have to worry about the pin flying to the 9th dimension. And where is the pin that we soldered? Can you tell? It's right here. If I do not like the way the pin looks, I'll grab it. We can apply a little bit of hot air. Okay, and done. The pin is soldered back on the CPU. Now if the pin is bent, or maybe you do not like the way the pin is aligned, then it's not a problem. Just grab a blade. We are zoomed in at the very top, at the very tip of the pins, so the bottom looks blurred. Maybe we can zoom out so we can see the whole picture. If let's say we have a bent pin, maybe you soldered a pin and the pin is bent, maybe the pin looks something like this, then what we can do is we can grab a blade and twist. Done. Maybe the pin is bent inwards or outwards, like this maybe. Then just rotate the board holder. We're gonna put a blade and fix. Done. We are done. I desoldered a pin, I applied solder onto the pad, and I soldered the pin back on the CPU. I can do this for one pin, or I can do it for 100 pins. The process is the same. Now Jay was complaining about a missing pad on the CPU. I did not see the pad as being missing on the CPU. To be honest, I think the pad still exists on the CPU. All you need to do is use a grinding pen, or you can use a blade to scratch oxidation of that pad. I do not think that Jay had a missing pad on the CPU. If I were to do this with a grinding pen, I would do this and grind that pad. I just grinded solder off that pad. Or we can also use a blade, the tip of the blade, which is more difficult, and just scrape off the oxidation of that pad. Now with the microscope that Jay had, it was not very clear if that pad was on the CPU or not, but I believe the pad is still on the CPU. I'm gonna apply solder on the tip like this. You see how that tip accepted solder? Such an amazing tip. We went through a lot of tips before deciding which tips to carry. Look at this tip. Apply solder here. Apply solder here. And apply solder here. We are done. Let's do this one more time. Just one final pin. I'm gonna desolder it maybe from here and put it here. And that pin is solid. To clean the area, I advise that you do not use an ear swab to clean a CPU because you're going to end up with something like this. Do not use napkins. Do not use anything with lint. I exaggerated the cleaning part just to show you that if you use an ear swab or napkin, then you're going to have lint like this stuck on the pins. So what should we use? A brush. You can look up this brush on our site. It's called a dual head brush. We have fine steel on the back here. And we have a semi rough brush on here. It's not too soft and it's not too rough. It's perfect for this purpose. Now what happens if we do not use flux? Let's apply solder on the pad here. Okay, you see this? Look at this. I'm not able to apply solder on that pad. I was able to do it here because probably we had some flux left on the tip and we are using a very good tip and a very good iron. But it's going to be difficult to apply solder, and if we are able to apply solder, then solder is not going to be round. And solder may bridge onto the next pad. I mean, I'm trying to apply solder and I'm not able to. And that's exactly what happened with Jay. Let's apply flux, just a tiny bit. And now let's try to solder. I need more solder. That's it, we are done. One last thing I want to go over before we end the video is I noticed Jay tried to desolder a current sense resistor off a video card and he was not able to. The reason for that is, again, a cheap hot air station. When working with video cards, and I do have a donor video card in front of me, that's the 3090 graphics card. With Jay's hot air station, he can point that station onto the component all day long. Maximum temperature and maximum airspeed, and he's not going to be able to desolder anything from that board. Or he may struggle to desolder a component of that board. What you have to understand is, since the board is 10, 12, 14 layers, I do not know how many layers the board is, when we apply heat onto the board from the nozzle, and of course you need a big nozzle because a small nozzle will supply less heat. You need a big nozzle for more heat transfer. But when we apply heat onto the board itself will absorb the heat and must reach the melting temperature of solder in order for you to be able to desolder or remove a component of the board. If the board itself did not reach the melting temperature of solder, then you're not going to be able to remove that component. Even though unleaded solder melts at what, 380, 400 degrees, and you are applying 450 degrees onto that component, you have to remember that the board is absorbing the heat. The board is absorbing all the heat, and the board itself must reach the melting temperature of solder in order for you to be able to remove that component. Now, to desolder that component, the first thing I want to do is use a bigger tip, a bigger nozzle tip, like this one here. And I believe this one is about 10 or 12 millimeters. And you can see how that nozzle goes over the one I have on my hot air station right now. Okay, and let's go under the microscope. Maybe we can go over this one here. I do not want to desolder the one next to the connector. I do not want to burn the connector, but I want to show you how it's done using hot air. And maybe I can go over other techniques to remove components off the board. You keep applying heat until the board is saturated with heat. And once the board is saturated with heat and it reaches the melting temperature of solder, then we will be able to desolder this component. It's a big component. Now, if I am to remove that component or replace it, I would not use hot air. I would use either low melt solder, or I would use my hot tweezers in combination with hot air. Okay, and I'm able to remove that component. I did not have to struggle. I did not damage that component trying to remove it. And the component is back on the board. The other way I would desolder this component is using the magic of low melt solder. I went over this in countless number of videos I have on the channel. I use low melt solder almost always every day. It's one of the best things that you can have on your bench. Low melt solder comes in a tube like this with 6 sticks, and a tiny bit of low melt goes a long way. I'll show you. And right now we do not want to use a microscopic tip like the NF.mini tip, but rather we want to use a big tip. Big tip means more heat transfer. If you use a small tip, it's not going to work because a small tip will not provide enough heat. So right now I have a big chisel tip right here. Before we apply solder, we have to apply flux. Let's desolder this resistor using low melt solder, just to show you other ways of removing this component. I have a low melt solder stick right here. And like I said, a tiny bit goes a long way. And let's do the other end. Flip the board, rotate the board, and we're gonna do the same thing right over here. So I did one side. What's gonna happen with low melt is it's gonna mix with unleaded solder, and it's gonna lower the melting temperature of solder. And low melt stays liquefied for 5, 6, 7, 10 seconds. So when I apply low melt solder on here, it stays liquefied. I go to the other end, I apply it from this side, and because this side did not harden yet, I'm able to remove this resistor. One thing you have to remember is to clean up, because you do not want to solder another resistor using low melt. Low melt is brittle, and with the tiniest amount of heat, it can liquefy. So we desolder it, just like that, and make sure you did not create any bridges. I do not have my anti-glare light on, and that's why we are seeing all this glare. So let's put the anti-glare light on, just like that. Now everything is nice and clear. Maybe we can zoom in a bit, and we can clean up later. I desoldered low melt from one pad, and maybe we can do the same thing here. We can clean up later, but why not do it now and later? Apply flux here, apply flux here, and now we're gonna apply leaded solder and not low melt solder. And we carry and sell one of the best leaded solder that you can get your hands on. Watch when I apply solder. Look at this nice shiny joint. We still have low melt solder on the sides of the resistor, because if you keep low melt on the component, then it's gonna mix with leaded, the one that we applied, and the combination of the mixture will be weak. All right. Now we can use hot air to solder that component back on the board, or in my case I can use hot tweezers because I have them, but let's use hot air. Grab that component, apply hot air. We're gonna have to wait until the board itself reaches the melting temperature of leaded, and then we can apply our component. The component is in place. We can press on the top and apply more hot air, and then the component is gonna settle in place, and you're gonna get a perfectly soldered component. Now we can make it look nice and pretty by applying more flux, and then we can touch up on the sides, but the component is soldered on perfectly and there's no need to do anything else for that component. We can go like this, and we can go like this, and we're done. I'll keep the component here in case we want to use it in the future, and that's why we have this donor board. I've actually used a lot of components from this board. If you look here, look at how many MOSFETs, DR MOS, we used of this board. 1, 2, 3, 4, 5. What else did I use? I used a lot of things from this board. And that's it, we are done. It's 7:20 right now and we close at 6. I had a few things to do, and also this video. I hope you enjoyed it. Let me know what you think, leave it down in the comments, and I will see you again in the next video.